Hello viewers, welcome to Cbse Maths class. In this video, I have come with the new chapter that is coordinate geometry. In class 9th also, introduction to coordinate geometry you have studied. There, how to plot the points on a Cartesian system you have learned. So again, little introduction to coordinate geometry. Coordinate geometry is the branch of mathematics which deals with the study of geometrical concepts using coordinate points on a Cartesian system. In coordinate geometry, we will use algebraic methods to solve the problems related to geometry. And where we use coordinate geometry in day-to-day real life situations. Shall we discuss that? Okay. So in day-to-day real life situation, you can see that it is widely used in space and technology for locating celestial objects, and civil aviation for locating the flights, and for architectural designs and mapping of roads in GPS, and computer science. And there are so many other fields also. This coordinate geometry is used. Few fields I have mentioned here. Okay. When it comes to comparison of geometry and coordinate geometry, how this coordinate geometry will use the points to solve the problems related to geometry. Okay, you can observe a few diagrams have written to the left and to the right. The left line segment, a triangle, and a parallelogram PQRS. The same figures I have taken to the right also. In geometry, you have learned how to find out the length of the line segment, and for triangle, how to find out the sides of the triangle. And here you can say LU is the altitude of the triangle, how to find out the altitude. And PQRS is a parallelogram, how to find all of its sides, and also how to find the perimeter and the area. All these things you have learned in your general plane geometry. All these problems can be solved in coordinate geometry also. The difference is here we will use only the coordinates to find out the length of AB, and here the sides of the triangle LMN, and the altitude you can say LU, and area of parallelogram PQRS, or how to find the sides of the parallelogram PQRS, so on. Very few I have taken. Okay, like that, any geometrical problems we can be solved by making use of coordinate geometry. Here we will use only the points to find out either lengths or area or even the volumes also. In volumes, it comes under 3D geometry that you will be learning in class 11th and 12th. Okay, in class 10 to find out the lengths of the polygons, we require the formula to find out the distance between 2 points. To find the length of AB or length of LM, length of MN, and length of LN, we require a formula to find out the lengths of the polygon. So first let us derive the formula for distance between 2 points on a Cartesian plane. Okay, I have drawn the diagram. Let A x1 y1 and B x2 y2 be the 2 points on a Cartesian plane. We need to find out the distance between 2 points A and B. Okay, for that little construction is required. Draw perpendiculars from the point A and from the point B on x-axis, that is AD and BA, and also one perpendicular from A on BA, that is AC perpendicular to BA. So as I told you earlier, you have learned how to plot the points on a Cartesian system. Okay, so in this Cartesian system, we have plotted the points A and B. What do you mean by the point A? Point A, x1, y1. It is a distance of x1 from origin to y-axis. Its x-coordinate is x1. And the distance from x-coordinate to that point A is nothing but y1. So the point A, x1, y1 represents the distances from origin to that point, from x-axis to that point, and y-axis to point A. So here, the distance from O to D is nothing but its x-coordinate distance. This gives you x1. Okay. The distance from O to E is the x-coordinate distance, that is x2. That means the length of DE is equal to x2 minus x1. That is nothing but OE minus OD. OE is equal to x2 and OD is equal to x1. Let me write that. So you can say AC is equal to DE, which is equal to OE minus OD. OE minus OD. So which is equal to x2 minus x1. That means length of AC is equal to x2 minus x1 and keep this number 1. Similarly, shall we find the length of BC? BC is equal to, from the figure, that is BE minus CE. BE minus CE. What is the length of BE? BE, its y coordinate of B, that is equal to y2, minus length of CE, the y coordinate of the point A, because AD distance is equal to CE. CE is equal to AD means the y coordinate is y1, y2 minus y1. So keep this as equation 2. Okay. We need to find out the length of AB. What kind of triangle is this ACB? ACB is a right angle triangle, no? In right angle triangle ACB by Pythagoras theorem. All of you know Pythagoras theorem, no? Pythagoras theorem. We can say, which is the right angle there? Angle C is right angle. Okay, therefore AB square is equal to, AB square equals AC square plus BC square. AC square plus BC square. Okay. In the figure, tell me what is the length of AC? AC equals from equation 1, that is x2 minus x1. So shall I write this AC as x2 minus x1 whole square plus what is the length of BC? BC is equal to y2 minus y1. y2 minus y1 whole square. This is nothing but AB. Okay. AB square. We need the length of AB. To get the length of AB, take square root on both the sides. So what does your AB represents now? AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is very, very important formula to find the length of the sides of any polygon or to find the distance between any 2 points. Okay, this is the derivation for distance between 2 points. How this formula will be useful, we will see in the problems in the coming part of the class. So the first question asked based on this distance between 2 points. Find the distance between 2 points, -1 minus 7 and 8 minus 3. So what you do is let A equals, let us mention this A point as -1 minus 7, comma, B is equal to 8 minus 3. Okay. So what is the distance between these 2 points? Okay. Shall we apply the formula to find out the distance between 2 points? AB is equal to, just now we have derived this formula. AB is equal to what? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. What is x1 and y1 and x2, y2? First point represents what? x1, y1. The second point B is nothing but x2, y2. So it is very clear in the formula that we need to substitute x2 minus x1. That means the difference of their x coordinates. x2, what is the x2 in the given point? 8 minus x1 is -1. 8 minus of -1 whole square. What is your y2? Y2 is equal to -3 minus y1 is -7. Minus of -7. Be careful when the negative signs are there. So that gives you square root of, what is 8 minus of minus means 8 plus 1. 8 plus 1 is equal to what? 9 square. What is -3 plus 7 is equal to 4. That is 4 whole square, which is equal to square root of 9 square is 81 and 4 square is 16. So which is equal to root of 1 plus 6 is 7, 8 plus 1 is 9. So the length of AB is equal to root 97 units. So if you find the 2 point, write 2 points A and B. On a Cartesian system, if you find the length of AB, the length of AB is equal to root 97 units. So the next question is a very interesting problem. If a point 02 is equidistant from the points B and C, there are 3 points here, A, B, and C. A is equidistant from the points B and C. Okay, in that points B and C, there is a alphabetical value letter, that is P. That P value you need to find out. So A is given as 02 and B is given as 3P and the point C is given as P5. Already clearly it is mentioned in the question itself that A is equidistant from B and C. So it is given that AB is equal to AC. Because from the points B and C, A is at equidistant, at the equal distance. So if we don't want to use the square root, AB means what? Root of x2 minus x1 whole square plus y2 minus y1 whole square. AB square, if I make it, what happens? You need not use the square root. AB square is equal to AC square, squaring on both the sides. So let me write down, for finding AB square, what is our A? A is nothing but 02 and B is 3P. P is 3P. Okay. And here for finding AC square, A is once again 02 and C is nothing but P5. Okay. Shall we apply this formula? X2 minus x1 whole square. What is your A02, x1, y1 and this is x2, y2. B is 3P, no? And here also for while finding AC square, this is your x1, y1 and is your x2, y2. So for both you apply the formula, distance formula. Okay. So AB square is equal to what? X2 minus x1 whole square. What is your x2, sir? X2 is equal to 3. 3 minus 0 whole square plus y2 minus y1 is nothing but P minus 2 whole square. Because y2 is equal to P and y1 is equal to 2. P minus 2 whole square. In AC square, what is your x2? X2 is P minus x1 is 0. X2 minus x1 whole square plus y2 minus y1 whole square. It is 5 minus 2 whole square. Here I am not using the square root because we are finding AB square and AC square. So the next 3 minus 0 whole square is equal to what? 3 whole square. Or shall I write directly its value? 3 whole square gives you what, sir? 9, you know. 3 whole square gives you 9. P minus 2 whole square. Expand A minus B whole square. P square, A square. B square means whole 2 square is 4. Minus 2AB, 2 into 2, 4, 4 into P, 4P, 4P is equal to P minus 0 is P, P whole square is equal to P square, plus 5 minus 2 is 3, 3 whole square gives you what? 9. Okay. So on either sides we have equal terms, that is P square and P square will cancel and 9 and 9 will cancel. What is left over for us? 4 minus 4P is equal to 0. So 4 is equal to what? 4P. Okay. So from here, don't get the point value of P now. So that is 4 and 4 cancels. That gives you P is equal to 1. The value what is asking in the question, P is equal to 1 we got. If you want, we can verify it. What is that verifying? AB square is equal to AB is equal to AC. We have to verify AB is equal to AC. We will verify for the given points now. What is our A? 02. A 02 and B is what? 3P. That is 3 and P value 1 we got. A once again 02 and C is equal to P5. This is 1, 5. Okay. Shall we use AB, that is AB is the square root of x2 minus x1 whole square. 0 minus 0 whole square is 0 whole square plus x2 minus x1. 1 minus 2 whole square. That is 1 minus 2 whole square is equal to AC is equal to what? 1 minus 0 whole square plus AB is equal to, is it correct? P is equal to 1 we got. What is your P? 3, 1. Okay, 3, 1. A is 0, 2. P is 3, 1. And A is 0, 2. And P is equal to 1, 4. 1, 1, 5. 1, 5 only correct? 1, okay. So when you simplify this, what you are going to get? 0 whole square is 0. 1 minus 2 whole square is equal to minus 1 whole square. Is equal to, and here we need to substitute further now. That is 1 minus 0 whole square plus 5 minus 2 is equal to what? 5 minus 2 whole square is equal to 1 minus 2 whole square is root of 1 square is 1. 5 minus 2 whole square is equal to what? 3. 3 square is equal to 9. Somewhere some value is missing. We are not getting correctly. Have we substituted correctly? For the given values 3p and 0, 2. A is equal to 0, 2 we have substituted, and B is equal to 3p. B is equal to 3p, correct? That means 0, 2 and here 0, 2, p5. So on simplification, what we got? 3 minus 0 whole square plus p minus 2 whole square. Okay. So A is equal to 0, 2, P is equal to what? C is equal to P5. C equals P5. Same values we have used. 3 minus 0 whole square plus P minus 2 whole square is equal to P minus 0 whole square plus 5 minus 2 whole square. 5 minus 2 whole square is 3 square is equal to 9. Okay, for these values, it's not satisfying. I can 3 minus 0. Okay, 3 minus 0 is what? 3 whole square. It is not 0. It should satisfy. Okay. We have not substituted value correctly. Here, when you substitute what? 3 minus 0 is equal to 3 square. Okay. I'll replace these values once again. I'll substitute in AB and AC. Okay. AB and AC. See, if you don't substitute properly, here itself you will be get caught that you are not getting the correct answer. So let me substitute this as a root of x2 3 minus 0 whole square is equal to 3 square plus 1 minus 2 is nothing but minus 1 whole square. Here for 1 minus 0, 1 whole square plus 5 minus 2 is equal to 3 whole square. That gives you root of 9 minus 1 whole square is 1 is equal to square root of 1 square is 1, 3 square is equal to 9. Root 10 is equal to what? Root 10. That means what value of P we got is correct. So some more application problems based on the distance between 2 points we will discuss in the next video. I hope all of you understood how to use the distance formula based on the question given to you. What we learned in this class? Introduction to coordinate geometry, applications of coordinate geometry, how this geometry and coordinate geometry are interlinked, and how this algebra is used in coordinate geometry in place of normal method in plane geometry. And we have derived the formula for distance between 2 points and the problems based on distance between 2 points. One simple problem to get the distance between 2 points. And the next question, to find a point which is equidistant from 2 given points. To find the unknown value P when a point P which is given to you, which is equidistant from 2 given points. I hope all of you understood the concepts which are discussed in this class. So I will come with some more good problems in the next video. That's all from this video. Have a good day. Thanks for watching.